Thank you, and as I sometimes say, and now to something completely or nearly similar. So, to Lars's journey that he told us about, my journey is very much the same. I also, as you can see on my age, started in the expert system artificial intelligence back in the 80s, and have been being there during the AI winter, and now we are working with AI again, and it's very, very interesting. I'll be talking specifically about speech recognition. So using AI, the new AI tools for speech recognition, that will be my topic. So I'll not be saying anything about large language models or things like that, but what we are doing in the area of making audio into text, actually. We have been in the business for many years, and we have been doing a lot of different kinds of speech recognition solutions, as these pictures illustrates. Some of them are for parliaments both in Denmark and in Norway, where we make a translation of what is said in the parliament to text. So we make some kind of first version of the text, and we also do it for, this is the impeachment of Inger Støjberg in Denmark, as you might, the Danish people might know. We made an automatic transcription of what was said during all the days in the court, and today it's a book of more than 1,000 pages of what's being said in the impeachment, and we make for translation to subtitling, and we also do for logistics. So we use speech recognition for a lot of different kind of use cases. And last week we launched one for the Faroe Islands as one of the first that made a speech recognizer for the Faroe Islands, not because it's a huge market and we can earn a lot of money, but because we would try to use the new AI as a full AI solutions for speech recognition on a low resource language where you have very limited data, because that's also always our problem, that we have not enough data to train on. But some of these models you can train, some of these solutions you can train on top of existing pre-trained models, and that has been a very, very exciting thing for us to do. So what we did for the Faroe Islands was that we used the Metas pre-trained model for 120 different languages, except Faroe Islands. It could Icelandic, and it could Norwegian and Danish and Swedish, but it couldn't understand the Faroe Island language. So therefore we tried to do this with very limited data. We had only about 150 hours of annotated audio, but we used different kind of techniques, coming back to the synthetic data that we discussed before, where we amplified data, we manipulated data, we annotate, we changed the audio, but with the same annotation. So in that way we could triple the amount of data we had, and therefore we could make a speech recognition solution for that. So we used it trained it first for one iteration with the authentic data, and then we manipulated it and trained it again, and manipulated and trained it again, and then we went back and then we manipulated. So that was also what Lars told about. In this area, you do a lot of iterations. You have a good idea, you test it, you try it, and then you need to have very good test tools to find out if it's helpful or not, and then you have to try again. We have done a lot of our things on gamer computers. We were not in the PlayStation situation, but we have used the graphical cards, also the NVIDIA graphical cards. So we have used a lot of money in buying up gamer computers, often refurbished gamer computers, and put our own training center where we use these. And we have come actually a long way with using this. Maybe because we don't need that big amount of data as you need for large language models. To train the models for acoustic recognition, you need need a lot of data, and as the more, not always the more the better, but we need a lot of data. But you can still do it on gamer computers, but it will take a long time. So, but we have gained a lot of experience. We have built a lot of good solutions, both with the open source from different universities primarily in the US, but also on the Whisper model from Open AI, and it has been really a strong thing or a good thing for us that it has been open, that we can take the code down and we can take it to our own site and we can build on it, and we can secure our customers' data in a way that nobody else can, because we can build everything ourselves. But now we have come to a place where we would like to do something that is not possible to do on gamer computers. I have a small example here of just a calculation. We did a recognizer for New Norwegian, and it was, I don't know how many, of course there are Norwegian people here, so they know that in Norway they have one language with 8 or 9 different strong dialects, but they have 2 written languages, and there's no direct connection between the spoken language and the written language. But in the parliament, if you are a member of the parliament, you can say, I would like to be transcribed in New Norwegian, although I speak a dialect that is close to Bokmål, that is the other written language. So it would be sometimes same as if you in the Danish parliament said, okay, but I speak Danish, but I would like to be transcribed in Swedish. So there are very big difference, and as a Dane, it was a very big surprise that there actually was such a difference between it, and also that they can speak a Bokmål near dialect, but want to be transcribed in a New Norwegian transcription. But we made that. The problem was that only 1/10 of the data access that was accessible at the Språkbanken in Oslo were New Norwegian. 90% were Bokmål. So our recognizer there was very bad, but we generated a lot of data and so on, so we got up to 1,600,000 of data. But it took our gamer computer setup about 22 days to really train a new model on these data. And if we just theoretically calculated how fast could the Lumi computer do this, then it would be around 7 minutes if that we had no AI problems, input-output problems or so on. So if we want to add this to maybe 10 times or 50 times bigger, then it will be impossible to drive it on our. We can make a lot of testing and the first iterations, but then we need more computer power. So that is our goal. Our goal is to try and collect, first of all, as much data as we can in Danish, and then build it in Danish. But our main goal is to try and do it for all the Nordic data. Our idea is, and that is the idea that we want to prove, is that the North Germanic, what's it called? Germanic? The Swedish, Norwegian, Danish, Faroe Island, and Icelandic. These languages are very close to one another. Sorry for the Finnish. But we would like to build a speech recognizer on all the data, all the audio data that we can pool together for these languages together, and hopefully this will result in much better speech recognition for all of the North Nordic countries. And the reason why we believe that this is that the Meta pre-trained model and the OpenAI model, they are all trained on multilingual data. So they have maybe 100 different languages, but a lot of these, they differ very much from one another. And our theory is, and our previous tests are, that if we pool together languages that are very alike, then it will be maybe possible to get even better speech recognition. So that's our goal, and that's what we would like to use the Lumi computer that we have got access to. We are a company that is a member of Danish industry, and we have got through Danish Industry and Dike, we have got access to the Lumi computer in this autumn or early winter. So I think that was just to show you how the iteration goes when we are building speech recognition. It's like a lot of other developing processes. And I can also say the same as Lars said, a small dedicated team of very skilled people working very close together on a specific goal. That is a very, very strong way of developing things. Okay. Thank you.